Exercise question. The question is, the storage battery of a car has an EMF of 12 volt. If the internal resistance of the battery is 0.4 ohm, what is the maximum current that can be drawn from the battery? So here there is a car, means it's the resistance, and this car is connected to a battery of voltage 12 volt, and internal resistance of this battery is, so this is the battery, internal resistance is small r is equal to 0.4. This is the circuit and this one is the EMF of the battery. So how much current draw this car from this battery? So the question is ಒಂದು ಕಾರಿನ ಬ್ಯಾಟ್ರಿ ಇದೆ, ಆ ಬ್ಯಾಟ್ರಿ EMF ಎಷ್ಟಿದೆ 12 ವೋಲ್ಟ್ ಇದೆ, ಇಂಟರ್ನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ 0.4 ಓಮ್ ಇದೆ. ಸೊ ಹಾಗಾದ್ರೆ ಈ ಕಾರ್ ಏನಿದೆಯಲ್ಲ, ಈ ಕಾರು ಈ ಬ್ಯಾಟ್ರಿದಿಂದ ಎಷ್ಟು ಕರೆಂಟ್ ಅನ್ನ ಡ್ರಾ ಮಾಡ್ತಿದ್ದೀವಿ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ಹಾಗಾದ್ರೆ in this circuit we have a resistance and battery. Therefore the expression of current in a complete circuit, I is equal to E divided by capital R plus small r. So here they have not given the external resistance, therefore neglect this external resistance. The equation becomes E divided by small r. So I is equal to, the value of E is 12 and internal resistance is 0.4. This becomes 12 divided by 0.4. 30 ampere, 30 ampere. So a car can draw the 30 ampere current from this battery. So a car, a battery in the S current draw ಮಾಡ್ತೈತಿ 30 ampere current draw ಮಾಡ್ತೈತಿ. This is 3.1. Next in 3.2 question. The question is, a battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? What is the terminal voltage of the battery when the circuit is closed? So in a second circuit they have given a battery and external resistance and internal resistance. The circuit is a battery of EMF 10 volt and internal resistance 3 ohm. A battery of EMF is equal to, this is 10 volt and internal resistance is 3 ohm. R is equal to 3 ohm. Is connected to a resistor. So this is connected to a resistor, external resistor, that is capital R is equal to. So we are connected to a resistor. If the current in the circuit is 0.5 ampere, the current in the circuit I is equal to 0.5 ampere. What is the resistance of the resistor? So ಹಾಗಾದ್ರೆ ಈ external resistance ಎಷ್ಟು ಅಂತ ಕೇಳಿದಾರ. Next, what is the terminal voltage of the battery when the circuit is closed? So when the circuit is closed, what is the terminal potential difference across this battery? The terminal voltage of the battery when the circuit is closed. So EMF ಕೊಟ್ಟಿದಾರ, internal resistance ಕೊಟ್ಟಿದಾರ, right? Next current ಕೂಡ ಕೊಟ್ಟಿದಾರ. So can we calculate the external resistance with the help of the expression here? I is equal to, correct, the expression I is equal to E divided by capital R plus small r. So capital R plus small r is equal to E divided by I. So they have given the values. Capital R value ಗೊತ್ತಿಲ್ಲ ನಮಗೆ, plus internal resistance is 3, that is equal to EMF of the battery is 10 and current is 0.5. So 10 divided by 0.5 ಎಷ್ಟಾಯ್ತು? ಎಷ್ಟು? 20, right, plus 3 ಆ ಕಡೆ ಹೋದ್ರೆ minus 3, 20 minus 3, therefore R is equal to 17 ohm. So this is the external resistance value. R is equal to S1 value ಬರೋದು 17. ಇದು ಮೊದಲನೇ ಕ್ವೆಶ್ಚನ್ ಗೆ ಆನ್ಸರ್ ಆಯಿತು. ನೆಕ್ಸ್ಟ್ ಏನು ಕೇಳಿದರು ಅವರು, how to calculate the potential difference across when the circuit is closed, then the potential difference across the battery. So here we have the expression of the potential difference. The general expression of EMF is E is equal to V plus IR. So V is equal to E minus I R. What is the value of E? E value is 10 minus current is 0.5 and internal resistance is 3. So 10, 0.5 into 3, 1.5. So this is equal to, V is equal to, yes I know, 8.5 volt. So this, when the circuit is closed, this is the potential difference across the battery. So battery across the potential difference. This one is 3.2. Next, 3.3. The question is, at room temperature 27.0 degrees Celsius, the resistance of a heating element is 100 ohm. What is the temperature of the element if the resistance is found to be 117 ohm? Given that the temperature coefficient of the material of the resistor is 1.70 into 10 to the power minus 4 per degree Celsius. So the heating element is there, and this is a 3.3 question. 3.3. Heating element is there. Heating element at room temperature. So the heating element of the room temperature at room temperature. So room temperature is 27 degrees Celsius. 27 degree Celsius. This is the room temperature. Heating element is. At room temperature, the resistance of this heating element is 100 ohm. So initial temperature is 27 degrees Celsius. So T0 stands for, this is initial temperature. Initial temperature. At this initial temperature, the resistance R0 stands for initial resistance. Initial resistance. So from the heating element kottaravali, so heating element of room temperature dalli adara resistance estiದೆ andre 100 ohm ಇದೆ. 100 ohm. What is the temperature of the element if the resistance is found to be 170 ohm ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಹಾಗಾದ್ರೆ ಈ ರೂಮ್ ಟೆಂಪರೇಚರ್ ಇಂದ ಈ ಹೀಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಫೈನಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ 170 ಓಮ್ ಆಗಿದೆ. ಹಾಗಾದ್ರೆ ಫೈನಲ್ ಟೆಂಪರೇಚರ್ ಎಷ್ಟು ಅಂತ ಕೇಳಿದ್ದಾರೆ. ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ದಿ ಟೆಂಪರೇಚರ್ ಕೋಎಫಿಷಿಯಂಟ್ ಆಫ್ ದಿಸ್ ಹೀಟಿಂಗ್ ಎಲಿಮೆಂಟ್. ಈ ಹೀಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ಟೆಂಪರೇಚರ್ ಕೋಎಫಿಷಿಯಂಟ್ ಅಂದ್ರೆ ಅಲ್ಫಾ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು. ದಟ್ ಈಸ್ 1.70 into 10 to the power -4 per degree Celsius. So ಹಾಗಾದ್ರೆ they have given the question is on the heating element ಕೊಟ್ಟಿದ್ದಾರೆ. ಹೀಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ರೂಮ್ ಟೆಂಪರೇಚರ್ ದಲ್ಲಿ ರೆಸಿಸ್ಟೆನ್ಸ್ 100 ಓಮ್ ಇದೆ. ಹಾಗಾದ್ರೆ ಆ ಹೀಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ರೆಸಿಸ್ಟೆನ್ಸ್ 117 ಓಮ್ ಆದಾಗ ಆ ಮಟೀರಿಯಲ್ ಟೆಂಪರೇಚರ್ ಎಷ್ಟಾಗ್ತೈತಿ ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಸೊ ವಿ ಹ್ಯಾವ್ ದಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್. ಸೊ ಹಾಗಾದ್ರೆ ಕಂಡಕ್ಟರ್ ಕೇಸ್ ನಲ್ಲಿ ನಾವು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ, when you increase the temperature what happens, resistance will increase. We have the expression of temperature coefficient alpha is equal to R minus R naught divided by R naught into T minus T naught. So ಇಲ್ಲಿ ಕ್ಯಾಪಿಟಲ್ T ತಗೊಂಡಿರೋದ್ರಿಂದ ಇಲ್ಲಿ ಕೂಡ ಕ್ಯಾಪಿಟಲ್ T ನ ತಗೊಂಡ್ಬಿಡ್ತೀನಿ. This is T minus T naught. So they asked to find the value of T. ಹಾಗಾಗಿ ಈ ಟರ್ಮ್ ನ ಈ ಕಡೆ ಶಿಫ್ಟ್ ಮಾಡ್ಕೊತೀನಿ. T minus T naught is equal to R minus R naught divided by R naught into alpha. So they have given the values. T minus T naught is equal to, what is the value of R? R value is 117 minus R naught value is 100 divided by the value of R naught is 100 into the value of alpha is 1.70 into 10 to the power -4. So ಹಾಗಾದ್ರೆ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದ್ರೆ T minus T naught, this becomes 70 divided by, this is 1.7. 100 is nothing but what? 10 to the power 2 plus 2, 10 to the power plus 2. ಹಾಗಾದ್ರೆ 10 to the power plus 2, 10 to the power -4 ಅಂತ ಹೇಳಿದ್ರೆ ಎಷ್ಟಾಯ್ತದೆ? 10 to the power -2. So 10 to the power minus. So ಹಾಗಾದ್ರೆ this becomes T minus T naught is equal to 17 divided by 1.7. ಎಷ್ಟಾಯ್ತು? 17 divided by 1.7 ಅಂದ್ರೆ 10 into 10 to the power 2 minus 2 ಇದು ಮೇಲ್ಗಡೆ ಬಂದ್ರೆ ಏನಾಗ್ತೈತಿ? plus 2 ಆಗ್ತೈತಿ, ರೈಟ್? ಸೊ ಈಗ 10 into 10 to the power plus 2. So this is nothing but what? ಎಷ್ಟಾಯ್ತು? 10 into 10 to the power plus 2 ಅಂದ್ರೆ 100. 100 into 10 1000, right? So ಹಾಗಾದ್ರೆ T minus T naught is equal to 1000. T is equal to T naught ಆ ಕಡೆ ಶಿಫ್ಟ್ ಆಯ್ತು ಅಂದ್ರೆ 1000 plus T naught. They have given the value of T naught. T naught ಎಷ್ಟಿದೆ? 27 degree Celsius ಇದೆ. ಹಾಗಾದ್ರೆ 1000 plus 27 degree, that is equal to 1027 degree Celsius. So ಹಾಗಾದ್ರೆ this is the temperature of this heating element when its resistance is 170 ohm. So ಅಂದ್ರೆ ಇದರದ್ದು ರೂಮ್ ಟೆಂಪರೇಚರ್ ದಲ್ಲಿ ಇದ್ದಾಗ 100 ಓಮ್ ಇತ್ತು ನೆನಪಲ್ಲಿ. ಹಾಗಾದ್ರೆ ಈ ಹೀಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ 117 ಆಗಬೇಕಂದ್ರೆ ಇದರದ್ದು ಟೆಂಪರೇಚರ್ ಎಷ್ಟಾಗಿರಬೇಕು? 1027 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್. ಅಷ್ಟು ಟೆಂಪರೇಚರ್ ಆದಾಗ ಈ ಹೀಟಿಂಗ್ ಎಲಿಮೆಂಟ್ ದ ರೆಸಿಸ್ಟೆನ್ಸ್ 170 ಓಮ್ ಆಗ್ತೈತಿ, ರೈಟ್? ಇದು 3.3 ಕ್ವೆಶ್ಚನ್. The next problem is 3.4. A negligibly small current is passing through a wire of length 15 meter and the uniform cross section 6.0 into 10 to the power minus 7 meter square, and its resistance is measured to be 5.0 ohm. What is the resistivity of the material at the temperature of the experiment? So they have given a wire of a length is 15 meter and the area of cross section of this wire is equal to 6.0 into 10 to the power